All right, we copy that. Zeta, waiting on 3.6 Bravo.
T-minus 10 minutes usually signals the start of a mission, but on January 14, 2026, the clock counted down to an end. The International Space Station drifted silently over the dark side of Earth. Inside the Crew Dragon capsule, 4 astronauts watched their screens. They checked their straps. They waited for the command that would change history. For 25 years, the station had been a place where people stayed. Crews launched, worked for 6 months, and came home on schedule. The calendar always ruled the day. But this time the calendar didn't matter. A medical issue had forced the hand of mission control. One astronaut needed to come home, and they needed to come home now. You already know that space is dangerous. You see the rocket launches and the fire. But the real danger isn't the explosion, it's the distance. When you are 250 miles up, there is no ambulance. There is no emergency room down the hall. If a heart beats wrong, or a stone blocks a kidney, or an appendix bursts, you are on your own. For decades, engineers and doctors looked at this problem and saw a wall. They knew that if a true medical emergency happened, the options were terrible. You could try to treat it with a small medical kit on the wall, or you could try an emergency evacuation in a capsule that might not be ready. That fear has always been there, sitting in the background of every mission meeting. On January 7th, that fear became real. A medical problem emerged on the station. It wasn't a scraped knee. It was serious enough that doctors on Earth started clearing their schedules. They used the station's onboard ultrasound machine. This is a tool that uses sound waves to see inside the body. An astronaut on orbit held the probe. Doctors in Houston watched the video feed live. They looked at the shapes on the screen. They talked over the loop. They realized the equipment up there wasn't enough. They needed better scans. They needed a hospital. And that meant the mission had to end. This is the part most people miss. In the old days, ending a mission early was a nightmare. The Russian Soyuz capsules were the only ride home for a long time. They were reliable, but they were rigid. Schedules were set in stone years in advance. Moving a landing date was a massive logistical headache, but Crew 11 had a different ride. They had a SpaceX Dragon, and this machine was built differently. It was designed to sit there, plugged in, powered up, and ready to leave at a moment's notice. It was a lifeboat. On January 8th, NASA made the call, bring them home. The departure happened on January 14th. This wasn't a panic, it was a procedure. That distinction matters. Panic is when people run and shout. Procedure is when trained professionals follow a checklist they have practiced 100 times. The crew commanded by Mike Finke closed the hatch. They ran pressure checks. They confirmed the seal was tight. At just after 5 p.m. Eastern Time, the clamps released. Small thrusters fired. The capsule backed away from the station. The crew watched the massive outpost shrink in the window. They were leaving months of science behind. They were leaving the schedule behind. They were focusing on one thing: getting the patient to a doctor. The flight home took about 11 hours. That sounds long for an emergency, but in orbital mechanics, it is a sprint. The capsule has to wait for the Earth to turn underneath it. It has to line up with the landing site. If you fire your engines at the wrong second, you land in the wrong ocean, or you bounce off the atmosphere. The Dragon's computer handled the math. It calculated the burns. It managed the fuel. The crew monitored the systems ready to take over, but they didn't have to. The machine did the work. This is where the engineering really shines. Coming home from space is violent. The capsule hits the atmosphere at 17,000 miles per hour. That is fast enough to cross the United States in minutes. When metal hits air at that speed, the air can't get out of the way fast enough. It gets crushed. That pressure creates heat. Thousands of degrees of heat, enough to melt steel. The only thing protecting the 4 people inside is the heat shield. It's a layer of special material on the bottom of the capsule. It is designed to burn away. It sacrifices itself to save the ship. As they hit the atmosphere, the plasma built up. It glowed bright orange outside the windows. For several minutes, communication cut out. This is normal. The hot gas blocks radio waves. Mission control just sees a frozen screen. The families watching at home just hear static. You have to trust the math. You have to trust that the engineers who built the shield did their job. You have to trust that the bolts will hold. Inside the capsule, the crew felt the gravity build. After months of floating, their bodies suddenly felt heavy. Chests pressed into seats. Arms felt like lead. For a sick astronaut, that force is brutal, but it is the price of admission for returning to Earth. Then, the plasma faded. The radio crackled back to life. The capsule was falling through the lower atmosphere. Now came the mechanical test, the parachutes. If they don't open, the story ends. First, 2 small drogue chutes popped out to stabilize the fall. Then the 4 main chutes deployed. Huge canopies of orange and white blossomed above the ship. The speed dropped from a roar to a gentle drift. At 3:41 a.m., the Dragon splashed down in the Pacific Ocean off the coast of San Diego. This location wasn't an accident. SpaceX moved recovery operations to the Pacific for a reason. The Atlantic Ocean is busy. It has heavy shipping traffic. It has unpredictable storms. The Pacific site near California offers calmer water and closer hospitals. It keeps the flight path away from populated cities. That is smart planning. As soon as the capsule hit the water, fast boats were moving. They didn't wait. They were already there. They secured the capsule. They opened the hatch. Medical teams went to work immediately. The sick astronaut was stable. The system had worked. Let that sink in for a second. From the moment the decision was made to the moment they were in a hospital, the system held together. No new hardware had to be invented. No heroics were needed. The tools were already there. The Dragon was already docked. The recovery ships were already fueled. The doctors were already on call. This is what competence looks like. It isn't flashy. It looks like a boring day where everything goes right. But making spaceflight boring is the hardest engineering challenge in the world. Now look at the numbers. This was the first time in the 25-year history of the International Space Station that a medical evacuation happened. Think about that streak. Over 2 decades, hundreds of astronauts, thousands of days in orbit. Models predicted we would see a medical emergency every 3 years. Reality gave us 0 for a quarter of a century. That tells you how good the health screening is. It tells you how good the onboard care is. But you can't beat the odds forever. Eventually biology wins. Eventually a body breaks down. Crew 11 was the exception that proved the rule. And when the streak broke, the safety net caught them. There was a lot of noise about the silence. NASA didn't release the astronaut's name. They didn't say what the medical issue was. People online argued about it. They wanted to know. They felt like they owned the mission, so they owned the data. But NASA held the line. They stuck to the privacy laws that protect every worker in the country. Just because you fly in space doesn't mean you lose your right to medical privacy. This silence was actually a sign of strength. A weak organization would have leaked the details to get ahead of the story. A strong organization follows its rules, even when the pressure is high. They protected their person. That builds trust for the next crew. But the mission didn't end with the splashdown. Up on the station, things got quiet. Very quiet. Usually the station has a crew of 7. It's a big place, the size of a football field, filled with pumps, fans, computers, and experiments. It takes a lot of hands to keep it running. With crew 11 gone, only 3 people were left. Expedition 74 was down to a skeleton crew. NASA astronaut Chris Williams and cosmonauts Sergei Kudryavtsov and Sergei Mikhaev. 3 people to run a ship built for 6 or 7. You know what happens when a team gets cut in half. The work doesn't go away. It just lands harder on the people who stay. Every filter change, every water test, every alarm, it all fell on 3 sets of shoulders. They had to cancel a planned spacewalk. Spacewalks are dangerous and take days of prep. You need a full team to help the walkers into their suits and monitor them. With 3 people, the risk was too high, so they stayed inside. They focused on keeping the station alive. They prioritized the critical systems and let the rest wait. This is where the automation pays off. Over the last 10 years, engineers have upgraded the station's software. Computers handle more of the daily tasks now. They balance the power grid as the station moves in and out of sunlight 16 times a day. They monitor the air pressure. They check the water recycling. If this had happened 20 years ago, a 3-person crew might have been overwhelmed. They would have spent every waking hour just flipping switches. Today, the machines carry some of the load. That bought the crew time. It allowed them to keep doing science even with half the staff. But you can't run on a skeleton crew forever. NASA needed to get boots back on the ceiling. The next mission, Crew 12, was scheduled for later in February. NASA looked at the calendar and decided to move it up. They targeted February 11th. Now, moving a launch forward is almost unheard of in the space business. Usually launches slip to the right. They get delayed by weeks, then months. Moving one to the left, making it happen sooner, is incredibly hard. It requires a supply chain that works perfectly. This is the second big reveal. The only reason they could move the launch up was because the hardware exists. The Falcon 9 rocket is reusable. The booster for Crew 12 had flown before. It didn't need to be built from scratch. It just needed to be inspected. The Dragon capsule, named Grace, was also a veteran. It had been to space, come home, and been refurbished. In the old days, building a new rocket and capsule took years. If you needed a rescue flight, you had to wait for the factory to finish the next one. Today, the rocket is parked in the hangar. You just have to gas it up and check the tires. That reusability changes the strategic picture. It means you have surge capacity. If something goes wrong, you can respond. You aren't stuck waiting on a production line that moves at the speed of government paperwork. SpaceX has launched the Falcon 9 over 300 times. They have landed it over 250 times. That repetition creates reliability. When NASA asked if they could fly sooner, SpaceX didn't have to invent a new plan. They just accelerated the one they had. Let's look at the crew that stepped up. Crew 12 is commanded by Jessica Meir. She's a veteran. She knows the station. Her pilot is Jack Hathaway, a rookie who trained for this moment. They are joined by Sophie Adenot from Europe and Andrei Fedyaev from Russia. 4 people from different parts of the world, strapping into an American capsule to save the schedule. This shows that even when politics on Earth are messy, spaceflight forces cooperation. You can't run the station alone. You need the seats. You need the partners. The launch prep for Crew 12 followed the standard flow. The rocket rolled out to the pad at Cape Canaveral. It stood vertical, gleaming white against the Florida sky. The crew went through their dry dress rehearsal. They put on their suits. They rode the elevator up the tower. They climbed in. They practiced the countdown. This wasn't a rushed panic drill. It was the same boring, methodical process as every other flight. That is the victory. The emergency response looked exactly like a normal Tuesday. And here's the thing about that capsule, Dragon Grace. It uses a heat shield that has been improved over time. Early versions had some issues with erosion. Engineers saw more wear on the tiles than they liked. So they changed the materials, they tweaked the design, they didn't hide the problem, they fixed it. That iteration is why the system gets safer. Every time a Dragon comes home, they drill samples out of the shield. They look at it under microscopes. They learn. By the time Crew 12 climbed in, they were riding on thousands of lessons learned from previous flights. When Crew 12 launches on February 11th, they will restore the station to full strength. They will dock automatically. The Dragon uses lasers and cameras to find the port. It flies itself in, adjusting its position by fractions of an inch. The crew watches the screens, ready to grab the stick, but the computer is faster and more precise. Once the hooks drive shut and the hatch opens, the station breathes a sigh of relief. The workload gets shared again. The spacewalks can go back on the schedule. The science returns to full speed. This entire sequence of events, the illness, the evacuation, the short-staffed gap, and the rapid replacement, proves something important. It proves that we have finally built a transportation system that is robust. It isn't fragile anymore. In the shuttle era, a problem could ground the fleet for years. After the Columbia accident, the station relied entirely on Russia for a long time. Now there is resilience. There are options. If a crew needs to leave, they leave. If a new crew needs to launch, they launch. The system bends, but it doesn't break. Think about the near-miss moments we never hear about. The weather in the Pacific could have been bad. High waves can flip a capsule or make it hard to get the crew out. If a storm had been sitting off San Diego, Crew 11 might have had to wait in orbit, sick and anxious. But the weather team modeled the waves. They picked the window. They threaded the needle. Or think about the Falcon 9 booster for Crew 12. If a sensor had failed during testing, the launch would have slipped back. The station crew would have been alone longer, but the hardware held up. These things go right because thousands of people pay attention to the details every single day. The medical capabilities for the future have to get better. Crew 11 came home because the station didn't have the right diagnostic tools. They needed a CT scan or an MRI, and you can't fit those on a rocket. Not yet. But this event will push engineers to fix that. They are already working on smaller scanners. They are developing AI tools that can help astronauts diagnose problems without a ground team. If we want to go to Mars, we can't turn around and come home. Mars is a 9-month trip one way. There is no quick evacuation. The Crew 11 flight is a warning and a lesson. It tells us exactly where the gaps are before we commit to the long haul. The privacy policy will also be a model for the future. As space travel becomes more common, more people will fly, more people will get sick. We can't turn every medical event into a reality TV show. The discipline NASA showed here sets the standard. It says that health is personal, even when the mission is public. It allows astronauts to be honest about their symptoms without fearing they will be splashed across the front page. That honesty saves lives. If you fear the headline, you might hide the pain until it's too late. The competitive landscape is shifting too. China has its own station, the Tiangong. They fly 3-person crews. They have their own medical protocols, but they don't have the same flight rate as SpaceX. They launch once or twice a year. SpaceX launches over 100 times a year with satellites and crew. That cadence builds a deep base of data. When you fly that often, you see every edge case. You see how valves stick in winter. You see how sensors drift in summer. You fix the small things before they become big things. That is an advantage that is hard to copy. It is earned in sweat and fuel. The return of Crew 11 also highlighted the cost efficiency of the commercial model. In the old cost-plus contracts, an emergency mission might have cost billions. It would have required special appropriations from Congress. Here, the mission was already paid for. The hardware was already bought. The early return changed the schedule, but it didn't break the bank. The Crew 12 launch was already on the books. They just shifted the date. This flexibility is what makes modern spaceflight sustainable. It stops being a special event and starts being infrastructure, like a train schedule. Sometimes a train is early, sometimes it's late, but the rails stay open. Let's verify the victory here. The mission objective was to bring a sick crew member home safely. Result accomplished. All 4 astronauts landed safely. The objective was to keep the station running. Result accomplished. No systems failed. The objective was to replace the crew quickly. Result on track for February 11th. By every metric that matters, this was a success. It wasn't the mission they planned, but it was the mission they executed. The magician moment here isn't about pulling a rabbit out of a hat. It is about taking a terrifying problem, medical crisis in orbit, and making the solution look routine. The magic is the checklist. The magic is the heat shield that works every time. The magic is the rocket that lands so it can fly again. We used to look at space and see a place where one mistake meant death. Now we look at it and see a place where mistakes can be managed, where problems have solutions. Crew 11 showed us the limit of what we can handle on orbit today. It reminded us that we are still biological creatures in a harsh void. Our bodies are the weak link in the chain, but it also showed us that the machines we built to protect those bodies are up to the task. The Dragon capsule performed as a true lifeboat. It proved that emergency evacuation isn't just a line in a manual. It is a real capability that works when the chips are down. The gap between what we thought was possible and what is now normal has closed. 20 years ago, the idea of a private company launching astronauts was a joke. 10 years ago, the idea of reusing rockets was a fantasy. Today, we have a private ambulance service from low Earth orbit. We have a logistics chain that can shift gears in weeks, not years. The impossible became the routine so slowly that we almost forgot to notice. When Crew 12 lifts off, they will ride a pillar of fire back to the station. They will fill the empty seats, they will get back to work, and they will do it knowing that if the worst happens, there is a way home. That confidence changes everything. It allows them to focus on the science. It allows them to sleep a little better in their floating bunks. The system has been stress tested, and it passed. Crew 11 came home early, but they didn't fail. They proved that the safety valve works. They turned a potential tragedy into an operational statistic. The station kept flying, the rockets kept launching, and the frontier got a little bit safer for the next person who climbs aboard. That is how you build a future in space, not with perfect missions, but with resilient ones. The lesson is simple: be ready, be fast, and trust the hardware you built to bring you home.